All right, we'll continue now. The next lesson is quite short. Can we look up? Yep, guys. So what we're looking at now, quite short, it builds on the last lesson. We talk about mutually exclusive and independent. So sometimes in our Venn diagram, we have situations like this, where the intersection is 0. So what does that mean about the events A and B? What can we say about the event A and B? They can't happen together. Okay, it's not possible to see an A and a B at the same time. So in this situation, when probability of A and B is equal to 0, we say that A and B are mutually exclusive. I just said what it means. When A and B probability equals to 0, we say A and B are mutually exclusive. That's the meaning. David, now be good. Yeah, and vice versa. Yeah. It's okay. It's a term you can use in English as well. When you're describing situations, it's not possible. It's not possible for the two situations to happen at the same time. We can say the two situations are mutually exclusive. Yeah? Okay. The next one's a little bit harder, but we'll have a look at it now. So that was the first one, mutually exclusive. Now on to independent. So you kind of have a rough idea of what independent means. It means that one event does not influence the other event. Okay, so one way you could say independent is the probability of A happening given that B has happened. That should be the same as the probability of A happening given that B has not happened. So can you see that the B, and that's equal to the probability of A. So can you see what you're saying here? Whether B happens or B doesn't happen, or you don't know if B happens or not, it has no effect on A. A and B are independent. This B, its effect on A is the same as its not having B effect on A, which is the same as not knowing whether or not B has an effect. B has no bearing on A. So an example might be your probability of rolling a 6, given that you just flipped a coin and got heads. No way does the coin affect the dice or vice versa. Yeah. So like for example, probability of rolling a 6 given that you just previously got heads, that would be the same as the probability of rolling a 6 given that you didn't get heads, which would be the same as just the probability of rolling a 6.
What was the point of writing them?
No, well, this is the definition of independent. And it's good if you know if events are independent because they're easier to calculate. What's nice about events which are independent is you have this result. Now this is a formula for independence, which kind of makes sense because we've seen it before. If A and B are independent, then that means the probability of A and B is equal to probability of A times the probability of B.
Why not plus?
Plus is OR. Now this should seem familiar. You've actually used this rule already. Where did you use this rule before? In what lesson? Which lesson? The tree diagrams. How do tree diagrams work? What do you do to calculate the probability at the end? You multiply along the path, don't you? So event 1 follows event 2. They multiply. Now it's not exactly like that. It's kind of just similar to it. Your A and B events here, they could be a sequence, one after the other, or they could be happening at the same time. So for example, if you roll a die and you flip a coin at the same time, what's the probability of getting a 6 and getting a heads? It'd be 0.5 times 1 over 6. Yeah? You can do that as long as they're independent. Yes? Yeah. So in the exam, they sometimes ask you to check if two events are independent. The way you check is if this is true. If this is true, we can say the events are independent. Or vice versa. If the events are independent, then we can know this formula is true. It goes in both directions. So typically in the exam, they might ask you to calculate A, calculate B, and then calculate A and B. And then they say, are A and B independent events? We can use this to check. Well, let me see. Every single class I've ever done, I've always given examples. But I think today I won't.
So that's an example.
No, I'm about to do an example. You know, if we just wait like 1 minute, an example will be coming right after the theory. Yeah, sorry, yeah, okay. Now, let's look at an example. Sorry, do you have that written down? Do you have that? Right. Guys, come on, my throat's getting sore, and I want to repeat myself. Now, let's have a look at some examples. So, we might look at, for example, two illnesses, for example. We'll say something like, the probability of having illness A, we'll say, is 4%. And we'll say that the probability of having illness B, we'll say, is 8%. Oh, sorry, 6%. And we'll say the probability of having both illnesses, A and B, is 2%. So, well, we'll calculate now. So if you have 100 people, how many in your group of 100 will have illness A? 4. And how many will have illness B? And how many will have both of the illnesses? 2. Now, this is quite simple. You don't have a lot of information, but you can answer a rather useful question. That is, are A and B independent? No. Well, let's calculate it. The way you're supposed to check is by using the formula PA times PB. Does that equal to PA and B? So is 0.04 times 0.06, is that equal to 0.02? I don't think it is. It's way off, isn't it?
Yeah, it's 0.2.
Yeah. So they're not independent. So what is the opposite of not independent? We call that no. Yeah, dependent. Or the actual word that we say in probability and statistics is interaction. So what we're saying is that By saying A and B are not independent, it means that there's some interaction between the two of them. For example, perhaps having illness A makes you more likely to have illness B. Or perhaps having illness A makes you less likely to have illness B. Regardless, we say that there's some interaction between the two, if they're not independent. Okay. There are some illnesses like this, where if you have one illness, it actually makes some other illness less likely to occur. Or maybe not illness, like genetic disorders. You know, perhaps having, I can't remember what it is. There's, yes, actually, there's having Down syndrome makes it less likely to have something else. I can't remember. Anyways, you get the idea that you can have an interaction between the. You have an example? Which one is it? That's it, sickle cell and malaria. Having sickle cell makes you less likely to have malaria. So is having sickle cell and having malaria independent events? No, there's an interaction between the two. Yeah? No, definitely. Definitely true. Yeah? Not maybe. Right, can we do some more examples? Can I scroll down? Interaction is just the opposite of being interaction is the same as saying not independent. This is very important for biology and for medicine. You want to know if your diseases and your illnesses are independent or not, or if there's an interaction between things. Okay, so let me give you another example here. Let's see. So, let's say you have 8 people. So, can I scroll down? And you ask each person what day of the week they'll have their birthday on. So maybe the first person says, I'll have my birthday on a Monday. And maybe the next person says they'll have their birthday this year on a Wednesday. What is the probability that you'll have 2 people who share their birthday on the same day of the week? Now, not the exact same day in the year. I'm just saying, like, maybe one person will have their birthday on a Monday, and another person in the group will also have their birthday on a Monday. So calculate this, please. Do you understand what I'm asking? No? I'm asking, what is the probability that 2 people will have their birthday on the same day of the week? So, for example, you have it on a Monday, and he also has it on a Monday. Now, it doesn't have to be the same Monday, just it's a Monday and it's a Monday, for example. Nope. 700% chance. No? Oh, were you saying 7 as in 2 over 7?
Yeah.
So, no, not 7 as an answer. Yeah. Also not this.
1 over 7 because like you're not like
1 over 7.
You're not taking like 2 days. You're taking 1 day for 8 people.
Oh, sorry. I gave you the wrong question. That's funny. Yeah. Sorry. Yeah, the one I gave you was not what I wanted. Sorry. That they all have different. So it was not that. So if you said 2 over 7, it's not that. The opposite, yeah. All have a different. They don't share. Nobody shares. Well, actually, no, that's fine. It just whatever answer you got for the last part. Yeah, whatever. So you can give me either answer. You can say no one shares, or what you just worked out that 2 people share. I don't mind, whatever you want. They're both the same question, really. Right. So I have a few answers for the first one. I have 2 over 7 and 3 over 7. Both are wrong.
No one shares.
Which answer are you giving me? The no one shares. What's that? We're getting there. Right, so the answer is, for the first one, Anyone want to give me the answer for the first one if they're confident? Okay. 1.
One.
Good for you.
1 and 0.
How many days of the week are there?
7.
And how many people are there? So, someone has to share their birthday with someone else.
I was also close.
And this one here?
0.
0. Yeah. Yeah. All right. Let me give you another one here. So,
Wait, no one shares it. 0. Okay, yeah, then.
yeah, next. What is the probability of winning a gold medal and the silver medal in an event? Yes.
0.
0. Why?
Because you have to
What's the word?
interact.
Mutually exclusive.
Sorry.
If you win the gold, can you win the silver? No. If you win the silver, can you win the gold? No. They're mutually exclusive. So what's the probability of winning gold and silver in the event? 0. Okay. Next one. Now I'll read this out. Listen carefully. So there's a woman about to give birth, and her previous 6 children.
What?
Yes. All of them are boys. Previous 6. Okay? You got that?
Yeah.
Previous 6, all boys. What is the probability that her 7th child is also a boy?
50%.
50%. Good. And what's the reason for that?
Is it a boy or girl?
No?
Within the middle.
Because they're independent.
Sorry.
Yes.
Does the previous 6 births have any effect on the 7th? No.
No, mother.
So, because, well, it would have had a great effect on the mother, yes, that is true. Would have had an effect on the probability? No. No. Okay. Because the events are independent. Now, you have to be careful because that's a trick question that you often see. A common mistake the student would make in the exam would be to do what? 1/2 times 1/2 times 1/2 times 7 times. No, you don't have to know that because that's the mistake. So it's good for you not to know that. What is the right answer?
Just 1/2.
Just 1/2. And the reason, if they ask you in the exam for 1 mark, is because the events are independent. Yeah? So the other example they have is if you flip a coin and you get heads 10 times in a row, what's the probability that the next flip will also be heads? It's still a half because the previous 10 flips do not affect the 11th flip's probability. Okay? But at this point you might suspect that the coin is not fair, but anyways. Okay. Let's give you another one here. Yeah, okay. Half of students are male and 80% of students study maths. So, probability of male is a half, and the probability of studying maths, that's 80%.
So female is half.
Huh? Yeah.
Yes.
Yeah, 8% or 80%.
That's a half, obviously. 10% of female students do not study. 10% of female studies do not study maths. So, how would I write that? 10% of female students don't study maths. Very good, given that. Now, what do I put on which side? Yeah, don't study maths.
Given it, so
Maths. Given that, yeah, this is equal to 10%. Okay? So, my question is studying maths independent of gender? Well, pretend you don't know the answer and calculate.
Oh.
Now, how do we calculate this? We need to calculate the probability of Mats and male.
That's me.
Oh yeah. Well, in other words, you might find it helpful to actually fill in the Venn diagram. So male and Mats here. Okay, so it might be useful to start with this one here. This is saying the probability of not Mats and not male over probability of not male, that's equal to 0.1. Now, which other number do we know here?
Not me.
This one, what is it? So if I cross multiply, what do I get? 0.05, isn't it?
Yeah.
So this here is equal to 0.05. Where is that on the Venn diagram? Not Mats, that's here, isn't it? Isn't it? Yeah. Yeah?
Yeah.
Okay.
Why 0.5?
0.1 times 0.5. I bring this up. This is 0.5. Now, we've seen this before, haven't we? What's the trick here? This one, make it equal to x. So what would this be?
0.5.
No, this one is Mats, which is 0.8 minus x. And here?
0.5.
Good. Isn't it? Minus x. And what should all of these add up to? 1. Yeah. So 0.8 minus x plus 0.5 minus x should equal 0.95. Cancel, cancel. 0.8 plus 0.5 minus 0.95 is equal to x. What's that? That's 1.3 minus 0.95, isn't it? 95 was this plus this plus this has to be 95. Because what's the total? And what's this? There. What is it? 0.35. Yeah? Okay, so here, this is 0.35. So what's that one there? 0.45, is it? And this one here? 0.15. Right, now we can check. So what's the probability of A and B? In this case here, Mats and male, 0.35. Does this equal 0.5 times 0.8?
No.
Yeah, isn't it? Yeah. 0.5 times 0.8.
No.
This is probability male and this is probability Mats. Well, what's this equal to? 0.4. Are they the same? Not independent. Yeah? So we say there's an interaction between gender and studying maths. Okay, so that was a little bit tricky. Yeah. Did you write that down?
No.
Okay, so just to finish, a couple of yes/no questions, or sort of one-word answer kind of questions. I just want to make sure you understand mutually exclusive and independent. So I'm going to give you some situations. I want you to tell me if you think the events are independent or not independent. So the first situation is I take one card from a deck, and then I take a second card from a deck. And please note, I don't put the first card back in. So I have a deck of cards, I take one card out, I look at it, throw it away, take a second card out and look at it. Okay? The first card and the second card, are they independent events or is there an interaction? There is an interaction, okay? Because, for example, whatever card you get first means it's impossible to get that second. So they can't be independent, okay? Now, how would I change the question slightly so that I can make those events independent? Put the card back in. And now they are independent events. Okay? Flipping a coin 3 times in a row, independent or interaction? Independent. Whether, if it rains tomorrow, on the next day and the next day, are the rain events independent or not? No, interaction.
Because of the season.
Yeah, if it rained today and then it rains tomorrow and then it rains on Wednesday, that will have an effect on whether it rains on Thursday. Okay, it's not like rain is flipping a coin, you know? Isn't right? Yes? Yes? Okay, so another example, the other example we did already was with gender. Oh yeah, so here's another example then that they might have in an exam. So you understand the word default on loan? Do you know what this means? Default on loan? It means you don't pay your loan back. Okay, so if you have one loan and you default or you don't default, it doesn't matter, and then you have a second loan and then you can default or you don't default. Independent or interaction? What do we think? Interaction, okay? If you default on your first loan, does that affect whether you're likely or not to default on the second loan? Yeah, it does. Right? Yeah? And lastly, can you think of an example in biology? You gave me the one earlier, but can you give an example in biology where having one disease interacts with another disease? That is, having one disease makes it more likely maybe that you have another second disease? Can you think of... Oh, HIV and... Really? And TB? And every other disease. Okay, all right.
Malaria
You said, which one? Having one makes it more likely that you have the other?
I don't know.
Yeah? Less likely. Yeah. Fine. I was looking for an example of more likely as well.
Malaria and typhoid.
Which one?
Malaria and typhoid.
Having one makes having the second one more likely. Okay.
Yeah, it actually does. Because most times when you go for malaria to end up testing for
Oh, okay. Right.
As if you have malaria, it will affect your liver. So the malaria has to break down your liver.
All right, that's okay, David. That's okay. That's okay. I like the first example of HIV and everything else. Yes. Okay. So what I need you to do, guys, what I need you to do from this one. They're very short questions, so you should be able to do all of them. Okay. Right.